All right, this might be one of my favorite lessons to teach and talk about, and it does involve the F word of math, which is factoring. Good old factoring. You've been factoring since Algebra 1, so hopefully this will be the time that it makes sense, it soaks in, and becomes something that's a little more natural. All right, so we're going to be talking about factoring. And factoring is ultimately patterns, so it's ultimately recognizing what to do and then the pattern that goes with it. So the very, 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 very first rule of factoring is always, always, always look for GCF, for a greatest common factor. Sometimes this will be the only thing you can do, or it's going to take you from something that looks a little more difficult to something that's more recognizable to solve. So first rule of factor, always, always, always look for a greatest common factor. So here's some examples. What if we have 3x plus 6? 3x plus 6. If I look for that GCF, we notice they have a 3 in common, so I'm going to take that out, and then we see what's left over. If I take a 3 out of 3x, I'm left with that x. If I take 6 and divide it by 3, or take the 3 out of 6, however you want to look at that, I'm going to be left with plus 2. I should know that my factoring is on the same page as where I started, because if I distribute that 3 back, I know I get 3x back where I started. 3 times 2 takes me back to 6. So I should feel like this factoring is probably complete. What about if we have x squared plus x? Again, looking for that GCF. So out of both terms, what do they have in common? They both share an x. So I can take out that x, and then I have my parentheses of leftovers. If I take x squared and take an x out of that, I'm left with a single x. If I take an x out of x, x divided by x leaves me with plus 1. So if I ever take out the entire factor, I got to remember to put that one placeholder, because when I distribute back, x times x gives me that x squared, x times 1 gives me back the x. If I didn't have that 1 right there, then I would lose this term altogether. What about 3ab squared plus 21ab minus 9a squared b to the 4th? 3ab squared plus 21ab minus 9a squared b to the 4th. Again, looking for that GCF, something that's in common with every single term. So it looks like if I look at the coefficient, the number, they all have a 3 in common. If I look at the variables, they each share at least one a. And if I look at the variable b, it looks like they each share at least one b. So I'm going to take out a 3, an a, and a b. And now we see what's left over. If I factor out the 3, the a, and the b, it looks like I'm left with 1b. Take the 3 out of the 27, or 21, I'll get a 7. The a and the b came out, so it looks like all I have is the 7. Here I have left over with a 3, one of those a's, and if I take 1b factored out, I still have b cubed left in my parentheses. So first rule of factoring, always, always, always look for a GCF. Second rule of factoring, we're going to check for the number of terms. We're going to check for the number of terms, because sometimes how many terms we have determines maybe what we're going to look to do. Get us started in the right direction of a plan, of a pattern. So we're going to check for the number of terms. Always look for the GCF first. Second, we're going to check for the number of terms. So let's see what we do with 2 terms. If I have only 2 terms. The first scenario might be that I have a difference of 2 squares. A difference of 2 squares. Sometimes referred as dots, D-O-T-S, difference of 2 squares. This would be the pattern that if I have one term squared minus a second term squared it's going to break down to two factors, where I take the square root of the first term. The square root of x squared would be x and x. The square root of a squared would be a, so I'll put a front, a back. Then I'll get one with a plus. One factor will carry a plus. The other one will carry a minus. So if I have two squares that are a difference, this will only work for a difference, then I can break it up to square root of the first, square root of the second, one factor with a plus, one factor with a minus. So let's see what this will look like. What if we have x squared minus 16? X squared minus 16. Look for a GCF. Any GCF? Nope, nothing they both share. I check my number of terms. How many terms do we have? 1, 2. Then I look at them. Do they happen to be perfect squares? Yes, I know the square root of x squared. I know the square root of 16. The last thing I check is it a difference? Yes, it's a difference. So it fits that difference of squares model, meaning I can take the square root of the front, x and x. I can take the square root of the back, 4 and 4. One gets a plus, one gets a minus. What about x squared minus 1? GCF? Nope. How many terms? 2. Are they both perfect squares? Yes. Sometimes we forget about 1 being a perfect square, but it's really a perfect everything. It'll be a perfect square, a perfect cube, a perfect fourth. So yes, it's a perfect square. Is it a difference? Yes. So it fits our difference of two squares model. Two factors. Square root of the x squared is x. So I'm going to put that front and front. Square root of 1 is 1, so it goes in the back and the back. One factor gets a plus, the other factor gets a minus. What about 100x squared minus 9? 100x squared minus 9. GCF? Nope, nothing they share. Two terms? Yes. Are they perfect squares? Yes. Is it a difference? Yes. Two factors. What's the square root of 100x squared? Well, the square root of 100 is 10. The square root of x squared is x. So we'll have a 10x, 10x. Square root of 9 is 3. So 3 in the front, 3 in the back. One factor with a plus, one factor with a minus. Let's see if we can squeeze one more in here. What about heart squared minus star squared? Heart squared minus star squared. GCF? No, nothing that heart and star share. How many terms? 2. Are they perfect squares? Why, yes, they are. And is it a difference? Yes, I have that subtraction sign. So 2 terms. What's the square root of heart squared? The square root of heart squared is just heart. So heart and heart. Square root of star squared is star. So star and star. One gets a plus, one gets a minus. This is meant to show you that factoring is patterns. It doesn't always have to be numbers, but it's recognizing if I have 2 terms, they're both perfect squares, and it's a difference. I can do it with hearts, I can do it with numbers, I can do it with apples, I can do it with oranges, that it's just recognizing the pattern. All right, let's see. A few more in this category. What if we have 2x cubed minus 50x? 2x cubed minus 50x. First rule of factoring, GCF. This time we have one. If I look at both these terms, do they share anything in common? Yeah, they both share a 2, and they both share an x. So I'm going to take that 2x out first, then see what's left over. Looks like if I take one x out, the 2 goes away, and I only have an x squared. Looks like 50 shrinks down to 25, and that x got factored out with the common factor. Is my factoring complete? Is that all I can do? No, if I look at what's left, what stands out? 2 terms, difference, both perfect squares. So just because I factor with one technique doesn't mean that I'm not necessarily done. So I owe it to myself to look and see if I can keep factoring. And so those perfect squares stand out. So I'm going to keep the 2x. Don't lose it. Still part of your factoring. But x squared minus 25 breaks down to x and x. There's the square root of x squared. Square root of 25, 5 and 5. One gets a plus, 1 gets a minus. This is our complete factorization. And one more here. What about x squared plus 16? X squared plus 16. GCF? Nope. Perfect squares? Yes. Got that 2 terms with perfect squares. Is it a difference? No, it's not a difference. So will this fit our difference of 2 squares model? No, it won't. This is a situation that's not factorable. I can't break this down anymore into factors that will multiply to give me back that x squared plus 16. So just because we see the 2 square roots, make sure that it has to work for a difference. It will not work for a plus. All right. So 2 terms, I could have perfect squares, but with 2 terms, I could also have the sum or difference of 2 cubes. I could have the sum or difference of 2 cubes. So again, kind of comes with a pattern. What if I look generically at x cubed, and I'm going to go ahead and do minus a cubed. X cubed minus a cubed. So what if we look at the difference? The only way to factor the sum or difference of 2 cubes is with this following pattern. So we have to know the pattern. If you recognize they're 2 cubes, the pattern will get you there. So every difference or sum of 2 cubes will factor into a binomial, trinomial. 2 terms, 3 terms. The first term comes from the cube root of the front, x, the cube root of the back, a. The front term here comes from the front term squared, so x squared. The term in the back comes from our second root squared, so a squared. And the middle comes from multiplying these 2 together, so I'm going to get an x times a inside. I'm going to do signs in just a second, but let's go ahead and do our sum. Pattern is exactly the same. So if I know they're both cubes, this time will work with a sum, work with a plus. And again, it breaks down to binomial, trinomial. So cube root of the front, cube root of the back, square the front, square the back, multiply the 2 in the middle. And how are we going to get those signs in between? We're going to remember that acronym SOAP. And SOAP stands for same, opposite, always positive. If I can squeeze that in. Same, opposite, always positive. So the pattern's the same, whether it's a difference, whether it's a sum. We're going to let SOAP do our signs. If I start with the difference, we're going to connect these with the same sign, minus, the opposite sign, plus, and the back is always positive. For the sum, we use that same SOAP pattern. So in this case, I'm going to start with the same, and this time plus, opposite, negative, and the back is always positive. Same pattern, let SOAP do your signs. So let's look at a few examples of sum of difference of 2 cubes. What if we have x cubed plus 8? X cubed plus 8. Again, GCF, going through the process, no GCF. How many terms? 2 terms. Are they cubes? Are they squares? Well, this big 3 right here kind of leads us into, let's think about cubes. And yes, 8 is a perfect cube. So the only way that I can factor a sum of 2 cubes is with that binomial, trinomial pattern. 2 terms, 3 terms. So here we go. Cube root of x cubed, x. Cube root of 8, 2. Square the first term, take x and square it. Square the second term, take 2 and square it. So I get a 4 in the back. The middle, I'm going to multiply these 2 together. I'm going to say 2x rather than saying x2. We'll start to look like an x squared again, and that's not what we have. We're multiplying these 2 together. I'm going to get 2x. And now SOAP's going to do our sign. So I'm going to start with the same sign, plus, opposite, and the back is always positive. This will never ever factor into anything more. So when we had up here, we did one thing and we could get some extra factoring in. If you're applying that sum or difference of 2's cubed pattern, this will never break down anymore. Once you've done your pattern, you are done. Okay? So don't try to do any more. What about circle cubed minus square cubed? Circle cubed minus square cubed. GCF. Nothing in common. How many terms? 2 terms. Are you looking at squares or are you looking with cubes? Well, this 3 right here says, looks like these are both cubes. If it's cubes, I can only use that pattern. 2 terms, 3 terms. 2 spots, 3 spots. How does the pattern work? I take the cube root of the first. So cube root of circle cubed is circle. Cube root of square cubed is square. First term squared, circle squared. Back term squared, square squared. Multiply them together, circle square. How do you connect them? Let SOAP do your signs. So I start with the same, the opposite, and the back is always positive. Again, factoring is patterns. It's not about necessarily knowing everything about the factoring or being scared when I see big numbers or shapes or different types of math symbols. It's about knowing that if I can recognize the terms, know my patterns, I can pretty much factor anything that I know will be factorable or not. Again, once I apply the cube pattern, I'm done. I'm going to move on. Last one of these, what about 125x cubed plus 1? 125x cubed plus 1. GCF? Nope, nothing in common. How many terms? 2. Perfect squares or perfect cubes? Again, 1's both, but then this cube lets me know that it's going to be probably cubes rather than the squares, and I should know that 125 is a perfect cube as well. Is it okay that it's a sum? Yes. For cubes, I can be both positives or negatives, sums or differences. If I can recognize that it's cubes, everything's going to fall into that 2-3 pattern. I take the cube root of the front. 125x cubed. Cube root of 125 is 5. Cube root of x cubed is x. So the cube root of the first term is a complete 5x. Cube root of the back. Cube root of 1 is 1. How do I get this term? I take the first term and square it. So I have to take all of 5x and square it. So that means it's going to be 5 squared, 25, x squared, x squared. Square the back, take 1 squared, it stays 1. Multiply these together, 5x times 1 becomes 5x. Connect with SOAP. Again, same pattern, whether it's plus or minus, I get the same exact values. Let SOAP do your signs. So same, opposite, always positive. We'll never factor anymore. First rule of factoring, always look for a GCF. Second rule of factoring is check your number of terms. If it's 2 terms, we're looking at sum or difference of perfect cubes and then a difference of perfect squares. Okay. All right, next, what if we have 3 terms? What if we have 3 terms? Okay. First thing that can happen is we have a trinomial with a coefficient equal to 1. Oh, can't totally see that. Here we go. 3 terms might be the case of a trinomial with a coefficient equal to positive 1. These we like the best. So this is kind of our common Algebra 1 factoring, x squared plus bx plus c. So trinomial being 3 terms with a leading 1 in the front of that x squared. So let's look at x squared minus 7x plus 12. X squared minus 7x plus 12. Again, start back at the beginning. First rule of factoring, GCF. Nope, nothing that all 3 have in common. How many terms do we have? 3. We got a leading coefficient of a 1, just a single x squared. So when we have a trinomial, we're going to break it down into 2 factors. This is where we think what multiplies to give us the back. but at the same time adds to give us the middle. What will multiply to give us the back, add to give us the middle. Well, what multiplies to be 12? So we're looking at maybe 3 and 4, taking us to 7. So we'll split up that x and x evenly. I want it to multiply to be positive, but add to be negative. So it looks like we need minus 3 and minus 4. Again, if you're unsure, I can always FOIL this back and see and multiply it out and see if I get back what I started. So x times x is x squared. Outside gives us minus 4x. Inside gives us minus 3x. So there's that minus 7x back. And then last, negative 3 times negative 4 gives us plus 12. What about x squared minus 3x minus 10? X squared minus 3x minus 10. No GCF, 3 terms, leading coefficient of 1 in the front. So we're going to undo that FOIL, undo that multiplication. I know I'm going to have x and x. I'm looking for what multiplies to be negative 10, adds to be negative 3. What multiplies to be negative 10 adds to be negative 3. So we're either looking at 10 times 1, 5 times 2. Which one can take us to 3? Well, it looks like 5 and 2 can. So we need a minus in the end. So I need my bigger number to be negative 5. I'll finish it out with a plus 2. Again, if I FOILed back, I should get back what I started with. What about 2x squared plus 14x minus 36? 2x squared plus 14x minus 36. First rule of factoring. Always look for a GCF. So it looks like I can take out a 2 this time. And I just shrunk down to x squared plus 7x minus 18. Now I went from something that had a coefficient in the front to something that's not, and will turn out that we probably like these a little bit better. But am I done factoring? Should at least look into it and see if I can do more. Is there anything that multiplies to be 18, adds to be 7? So we got 18 and 1, 9 and 2, 6 and 3. Any of those combinations take me to 7? Yes, 9 and 2. I want it to be a plus 7, so it looks like I'm going to let the 9 carry the plus and the back carry the minus, minus 2. Here's my complete factoring. Can't forget about that GCF, because if I would FOIL this, I would then need to multiply back the 2 to get where I started. And last one in this category, what if we have an x to the 4th plus 11x squared plus 28? X to the 4th plus 11x squared plus 28. GCF? No, nothing that all 3 share. Not a common coefficient, not a common variable. 3 terms with a leading coefficient of 1. But this is an x to the 4th, and this is an x squared. Well, if I look at my common pattern, this is an x squared, and this is an x. So if I could split up that x and x, my outside and my inside only had the x for the middle. So if I want to split this up, x to the 4th, but end up with an x squared as my middle term, I can follow kind of the same brain thought, divide that evenly with x squared, still think about what multiplies to give me the back, adds to give me the middle. So things that multiply to be 28, so it's that 28 and 1, 14 and 2, 7 and 4. Did any of those take me back to 11? Yeah, 7 and 4. So I can do everything's positive, so plus 4, plus 7. Same brain thought, just when I have that x to the 4th with an x squared in the middle, that reminds me that I can evenly split those. But because I started so high degree, I might need to look and see I can factor any more. Because I'm still left with 2 terms. This x squared and this 4 stand out as perfect squares, but can I factor those anymore? No, why not? Because do squares, I can't have a sum of 2 squares, it has to be a difference. So that plus right there keeps me from continuing. If this would have been a minus, I would have been able to break this down one more time. So this is my complete factorization. Another thing with 3 terms is what if I have a trinomial with a coefficient not equal to 1? What if I have a number in the front, an ax squared plus bx plus c? Some kind of coefficient sitting in front of that x squared. A couple examples here. 3x squared minus 19x minus 14. I still want to follow that same same factoring thinking. First rule of factoring, GCF. Nothing that all three share in common. 3 terms, yes. I check about that coefficient. This time I do have a 3 in the front. That's not going to go away through a GCF. My method of factoring is really guess and check. I know enough about what the factors should look like when I FOIL back to get here that I'm going to use that knowledge to guess and check my way backwards out of this. So here's the 3x squared. I know that those first terms together have to multiply to give me 3x squared. Well, really, what's the only way I can get a 3? Well, that's 3 and 1, and the only way I can get an x squared is split up x and x. So it looks like I know to FOIL back and get that first term, I'm going to do 3 and 1. But I can also control the back, because I know when I multiply the last, I better get 14. Well, what are my choices? I can do 14 and 1. I can also do 7 and 2. I then need to guess and check that my outside and my inside will FOIL back and get me 19. So what do we want to try? 14 and 1 seem a little large, so maybe try 7 and 2. If I put the 7 here and the 2 here, let's FOIL back and see what we get. I'm going to get a 3x squared. Outside's going to give me a 6x. I don't really know my signs here. Inside's going to give me a 7x, and the last gives me a 14. Do I have what I need in the front? Yes. Do I have what I need in the back? Yes. But will these two middle terms take me back to 19? No, they won't. So this tells me that those are not in the right order as factors. But before I give up on 7 and 2, let's see if we can rearrange. What if I put the 2 in the front and the 7 in the back? Use pencils. Now let's try it again. First I get 3x squared. Not going well, right? This time outside I have a 21x. Inside I have a 2x, and last I have a 14. So again, yay for the front, yay for the back. Will 21 and 2 take me to 19? Yes, if I get a minus 21 and a plus 2. So that tells me I need my negative with that 7 to give me the 21, and a positive with the 2 to get me the 2x. There would be my factors. Will some of you need to go through this guess and check process, sometimes get it right before you get it wrong? Yes. Will some of you do this in your head and get it right the first time? Yes. But again, I'm just showing you that I'm guessing and checking. I know what I can control in the front, I know what I can control in the back, and I'm trying to put it in the right order. If this 2 and 7 wouldn't have worked, I would have ruled this out and gone to 14 and 1 and tried again. But realize you have 2 spots to put them. I could switch them if I need be, but I should always be able to FOIL and know that I got the right answer. So let's try one more of these and we'll move to our last pattern. So 2x squared plus 15x plus 7. 2x squared plus 15x plus 7. GCF? Nope, nothing they have in common. How many terms? 3. Is there a multiplier in the front not equal to 1? Yes. So it looks like we're going to have to undo the FOIL with some guess and check. Again, I control what goes in the front. The only way I can get a 2 is 2 times 1. So I know I'm going to have 2x and x. In the back I have a 7. This is nice because what's the only way I can get a 7? With 7 and 1. Now I just got to put them in the right order to make sure I get that 15 in the middle. So I could put the 7 here and the 1 here. I'm just trying to begin with. If I know that, it looks like I have a 2 on the outside, a 7 on the inside. Will that take us back to 15? Nope. So that tells me I might need to switch. Maybe I'll put the 1 on the inside and the 7 on the outside. Now I get that 2x squared, yay. 14x on the inside, 1x in the middle. Yes, that will take me to 15x. And last I have 7. Everything's positive because I need 14 and 1 to add to 15. And I had my factors. I can FOIL this back. First, outside, inside, last. This combines to be that 15x, and I know I leave that problem with the correct factors. All right, very last type of factoring we're going to see. We're checking those number of terms. We've seen what to do with 2 terms. We've seen what to do with 3 terms. Now with 4 terms, our method's going to be grouping. Our method's going to be grouping. So let's look at x cubed minus 5x squared plus 2x minus 10. All right, if you have hung with me this long in this video and have watched it, here's going to be the magic word. So I want you on the top of the Factoring A worksheet, the worksheet that goes with our first lesson of factoring, I want you to write Sonic on the top of your paper. When you turn this paper in, I'll take all the people who have Sonic on the top of your paper. We'll do another wheel. We'll do another drawing in class if you are face-to-face, and I will mail you a Sonic gift card. So if you have made it through this video, yay for you, proud of you, look at you being that great student, doing what you're supposed to do. So on the top of this worksheet, you write the word Sonic. Don't tell your friends who haven't watched the video because you're just losing your chances. Write your Sonic. I'm going to check those worksheets when you turn them in, and we'll see who can get a gift card in the mail. See, told you I love prizes, so rewarding. Watching this video, love it, thank you. All right, 4 terms, grouping. How does this work? I do exactly what it says. I'm going to group the front 2, I'm going to group the back 2. And then I'm going to start back over with that GCF process. If I look just at these front 2 terms, what do they have in common? They both have an x squared at the most. So I'm going to take out that x squared, and I'm left with 1 single x and a minus 5. Now I'm going to look at this back set. What does these back set have in common? Well, it looks like I can take out a 2. I'm going to do a positive 2, and it looks like I'm left with an x and a minus 5. What I've just done is gone from 1, 2, 3, 4 terms, now to 1, 2 terms. And if I start over and look at those 2 terms, start with the GCF, what do those have in common? What does this term and this term have alike? They have an x minus 5. So that's what I'm going to take out as my GCF. I'm going to take out an x minus 5, and then I see what's left over. I have an x squared left over here. I have a plus 2 left back there. Since I started high with an x cubed, always owe it to yourself to see if you can do any more factoring to get the complete set. Definitely can't do anything with a single x, but here's an x squared. 2 terms. This stands out of a perfect square. Is this a perfect square? Nope. And it's a plus at that, so I know I'm kind of stuck with those factors there. And yay, grand finale. X cubed plus 3x squared minus x minus 3. X cubed plus 3x squared minus x minus 3. GCF for all 4 terms. Nope. How many terms? 1, 2, 3, 4. What's our only plan for 4 terms? Grouping. So group. I go back and start over. GCF with just the first group. What do they have in common? Looks like they share an x squared again. Then we see what's left over. Single x plus 3. I look in the back. What do they have in common? Looks like no coefficients, no variables, but they have that kind of negative. And knowing what I know about the grouping method, I want these 2 factors to be alike if it's going to be successful. I'm pretty close. So what should I actually take out? I should actually take out a negative 1. See if there is a negative. So it switches my sign and makes that a positive x, and it makes that a positive 3. And it's starting to shape up with what I know that grouping should do. Again, 4 terms down to 2 terms. GCF all over again. What do they have in common? They've got an x plus 3 that they share. Now we do leftovers. I pull out that x squared. all of this factor went away. So if I take out the entire factor, what do I got to put in its place? This case, I have a minus, and I got to put a 1. Because if I factor out an entire factor, we saw that at the very beginning of the GCF notes, I got to put that 1 placeholder. Am I done factoring? I glance over my factors and anything stand out? Woot woot, here's 2 squares. Are they connected with a difference? Yes. So this I can actually do. I can do some more. So here we go. I keep my x plus 3. 2 terms, perfect squares. What's the pattern for that? I take the square root of the front, x and x, the square root of the back. Don't forget 1's a perfect square. 1 and 1. 1 gets a plus. 1 gets a minus. There's my complete factorization. Again, thanks for sticking with me. You did great. Hopefully we'll be able to practice factoring and be a whiz at this.